So in theory, a quantum computer operates on its qubits using quantum gates and measurement. So the complex algorithms are composed of a fixed sequence of quantum logic gates, and a problem is encoded by setting the initial values of the qubits. The calculation usually ends with the measurement collapsing the system of qubits into one of the 2 to the n aging states, where each qubit is 0 or 1. So the outcome therefore be at most n classical bits of information. If the algorithm did not end with a measurement, the result is an unobserved quantum state. Therefore, in quantum computing, computation is decomposed by the use of 4 main models of great importance. That is quantum gate array, which is computation decomposed into sequence of few qubits or quantum gates. One-way quantum computer, which is computation decomposed into sequence of 1Q measurement bits applied to a highly entangled initial state or cluster state. A diabatic quantum computer based on quantum annealing, which is computation decomposed into slow continuous transformation of an initial Hamiltonian into a final Hamiltonian whose ground state contains the solution. And finally, a topological quantum computer, which is computation decomposed into the braiding of anyons in a 2D lattice state. So the behavior of quantum mechanics as it relates to subatomic particles explains the complex behavior of atoms. For instance, electrons can exist in multiple distinct states at the same time. This is known as superposition, and it's impossible to know for sure at any given instant what state an electron may be in, because the very act of observing the state, it changes. So subatomic particles can be entangled so that change to one influences another. So my idea is to develop algorithms for optimization problems in data storage and energy efficient data retrieval, with applications in autonomous vehicle systems and autonomous robots, with some influences on artificial intelligence. Therefore, in quantum computing, quantum logic gates are represented by unitary matrices. The most common quantum gate operates on spaces of 1 or 2 qubits. So, as matrices, quantum gates can be described by 2 to the n times 2 to the n sized unitary matrices, where n is the number of qubits that the gate acts on. The variables that the gates act upon the quantum states are vectors in 2 to the n complex dimensions, where n is once again is the number of qubits of the variable. So the base vectors are the possible outcomes if measured, and a quantum state is a linear combination of these different outcomes. Therefore, my work in quantum computing related applications, I will be exploring those applications in communications, distributed navigation, and system diagnostics. that includes cryptography, software debugging, and machine learning capabilities. The main objective is to concatenate quantum computing as a paradigm by fusing artificial intelligence in deep cognitive machine learning. In addition, my goal is to integrate cloud computing and multi-agent system software models in order to create mathematical algorithms and software models with applications in smart drones and intelligent robotic systems and platforms. To sum it up, Corp Inteltech R&D is based on the fusion of artificial intelligence and the integration of cloud computing and multi-agent systems. The focus is in the use of computing infrastructure, service delivery, data storage, scalable virtualization. Bionic engineering with artificial intelligence, deep learning in applied neuroscience. Robotics industry. The bionic hand and smart hand glove software platform integrates complex mathematical algorithms. Many of these software modules were developed with the Python and C++ languages. The main objective is to provide the control environment for the bionic robo-hand, servo motors, and actuators, thus providing human-like dexterity and hand-finger coordination and movement. Artificial intelligence algorithms are used and supported. Bionic hand artificial intelligence. Electrode sensors are placed on two nerves, that is the ulnar and median nerves, located in the human arm. These nerves normally would allow for certain sensations in the hand. The idea is to electrically stimulate those nerves, thus transmitting the signal to the smart glove and the bionic hand fingers to enable it for dexterity. The bionic hand receives information from the brain via the ulnar and median nerve, thus providing sense of feel, touch sensitive, essentially creating a loop to let the bionic robotic hand to communicate with the brain. Motor software. Here is an illustration of the software models which activate the motor movement. The software is created with C++ and Python, integrating solutions for pulse width modulations by controlling several analog ports located on the main computer digital platform. Wi-Fi communications protocol. Data is sent over Wi-Fi to any IoT device, including a PC computer and or an Android device. It also communicates with the bionic robotic hand in order to control neural movement of all bend sensors and joints. Analog signals and digital data is also transmitted to the servo controller and the servo motors on the bionic hand. Data and signals are also displayed on the PC screen as illustrated in this segment of the video. We performed theoretical research and practical applications and empirical development in areas of neural engineering technology. Artificial intelligence refers to a broad category of computing system is able to learn directly from data. It is made possible by the augment of data analytics, and applied by the introduction of machine learning processes together with deep learning methodologies. Deep learning applies to neural network. It is a subset of machine learning, integrating neural network techniques that enable systems to learn from large amounts of data, including artificial intelligence engineering, data and circuit signals equating the information from neural engineering stimulation. When the rules for stimulation have been met, stimulation is delivered to the determined output channel, or across two output channels for bipolar stimulation.